Welcome, I'm Mike, a Googler, a statistician, and I'm passionate about learning and sharing. Today, I'm a friend and I welcome you into my office. Today, we're going to revisit the section of videos that are related to BigQuery ML, but we're going to do something unique. We're going to use Kubeflow Pipelines to build a new model against data that we visited before. And we're going to see if that model's better and conditionally go to the endpoint from the previous model and replace it without any interruption. This is going to make a lot more sense as we get in. Let's first start by talking about components of what we're going to touch today. We are going to use three things. We're going to use BigQuery, specifically BigQuery ML, to build a different type of model than we did in the O3B video, or O3A, where we built a logistic regression using BigQuery. We're going to go back there and we're going to build a deep neural net using SQL. A pretty crafty thing that's just an amazing feature of BigQuery. We're going to do it from Vertex AI. We're going to use a notebook and we're going to send commands over, but we're not going to do it directly from the notebook. We're not going to do it from a training job like we might learn in the O4 or O5 series. We're going to do it from a Kubeflow pipeline. Now, that's this piece. Vertex AI has a service that runs pipelines, which are these things where you put components of code that run independently. They have inputs and outputs, and they connect with each other to form this execution graph. And they look at the dependencies and run things in order. Kubeflow Pipelines is this framework. We don't need to install our own runtime to interpret that and run it for us. Vertex AI has a pipeline service that we just feed it the code, the pipeline code, compiled, and it runs the infrastructure for us that runs the job. Putting these three pieces together makes this a very powerful thing, and we're going to talk about automation at the end today in the Q&A. The best thing we can do now is just jump in and start peeling this apart. So let me share my screen. And we are in the GitHub repository linked down in the description that got you here. I've rearranged a few things. Now that we're revisiting series, I've decided to make it a little easier to, let's zoom in on this a bit. Now we have this new directional flowchart that says, hey, do you have training data? No, pre-trained API is something I haven't covered in videos, but we perhaps will add in the future. When you have training data, AutoML, that was the O2 series. If you want to write code that's custom, you have choices now. Framework, do you want to use SQL? BigQuery ML. We did that in the O3 series, A and B so far, and today C. Or do you want your choice? Like TensorFlow is the O5 series, and that series of videos is started as well. Once you're into that SQL series, O3A and B videos already exist. We're recording through O3C right now. We're going to use pipelines. Now, what does that mean? Let's zoom into this graph right here that looks at these. When we did O2A, we went to BigQuery and we ran a create or replace model statement to create a logistic regression. And we stayed in BigQuery and we created predictions. And then in the O3B video, notebook, we took that model and we exported it to a Google Cloud Storage location. It's in a TensorFlow save format. And we uploaded it to Vertex, created an endpoint, deployed the model to that endpoint, and then created predictions against that endpoint. Well, that endpoint is still running. And today we're going to do something a little different. We're going to take our notebook and we're going to send commands from Kubeflow Pipeline, and we're going to say, go create this new model with BigQuery, a deep neural net. And let's grab evaluation metrics from it and from the previous model, compare them, and if the new model's better, well, let's export the new model, load it up to Vertex AI, and add it to the endpoint, move all the traffic to it, and then remove the other model from the endpoint. So we've essentially replaced it. We've created a challenger. The challenger wins. We deploy it and let it replace the existing. Now let's zoom out of that. Command minus. You can follow along in this video by just clicking into O3C and you'll get to that notebook. More importantly, we are going to do it live which you could also be doing if you had followed along in the videos, the O0 video setup environment, O1 create data. I think you have to do O3A and B to get the model ready. We're going to go to the console. And we're going to navigate over to Vertex AI, and we're going to take a look at what we created before, and then we're going to go into our notebook, and we're going to create all the content we need, submit it, let it run, and then evaluate what it's doing while it's running. Now I'm in Google Cloud Console. I'm going to go to the menu, navigate to Vertex AI. That'll be our starting point for all of this. And let's actually go straight to the workbench and immediately go into our notebook here. And I'm going to need to change my project. We've been working from project StatMike Demo 3 throughout this video series. So let me choose that from the project selector up here at the header. Then once I'm in there, the notebook instance that we've already created, just gave it a really crafty name, My Notebooks. Oops, I clicked into it to see the details. We want to click Open Jupyter Lab. I'll go back and select that. All right, so that's going to open Jupyter Lab for us. And then we just need to double click in, like in the O1 video, we created data. The O0 video, we set up this environment and we cloned the entire GitHub repository over. So it has the latest and greatest content of GitHub already pulled into here. We're going to click O3C. Now we have it live on a runtime. And while that's coming up, let's go back to Vertex and just take a look at what we're working with today. So under models, in O3A and B, we were working with a model created in O3A. It took the fraud data, which had this specific column that labeled the data as fraud 1, not fraud 0. And it had all these other columns that we used to build that training function. We trained the model to say, is this fraud or not? And we took that model in the O3B video and we exported it and we brought it into the models part of Vertex AI as O3B right here. And that is currently deployed to an endpoint. You'll see I've already been playing around with O3C. We can actually go in here and make sure we don't mess with ourselves today. We're going to delete where I was prepping for the video. So let's get rid of those 2 practice runs I did to make sure this video works out for us. Don't you think there's any funny business? We're going to build this live and we're going to deploy it live. We're going to work together and make this happen. But the O3B model is there and it's at an endpoint. If I click that, it's going to take me over to the endpoint section. Or actually, it's just going to display the endpoint there. I'm going to click on endpoints and look at the O3B endpoint. Remember, our naming nomenclature throughout this series of video is the notebook name is used to name the assets, whether that's a model or an endpoint or a pipeline. We have the O3B endpoint. Click into it, and it'll tell us what models are deployed into that endpoint that can receive those JSON packages of prediction request and return back, the prediction. And I see the O3B model is on that endpoint. What we're essentially doing today is trying to beat that model, trying to build a better one, evaluate to see if it's better. And if it is, go to this endpoint, bring the new model in. That'll be an O3C model, today's notebook. Bring it in and then take the O3B model out, but no interruption. Bring the O3C in first, give it all the traffic, and then take the O3B, the old model, away. The way we do this, we could write a bunch of Python to do all these things, and we're still going to write Python, But we're going to do it in a way that's compartmentalized in Kubeflow so that it's kind of easy to automate this thing. We'll talk about that. So O3C, the video you're watching right now is this one. The prerequisites, well, we clearly need to have built the model in O3A and deployed it to an endpoint in O3B so that we can now replace it with a better model. What I call the football play chart of this, all the different parts of Vertex AI were in a notebook. It is going to create a pipeline, and that pipeline is going to interact with BigQuery and then also interact with the prediction service, that's endpoints and models. And then the notebook at the end, we're going to hit that endpoint and get predictions from it. And there's actually a little crafty piece of this specific model requires us to do that differently than the other videos. What that looks like from a console user's point of view is they've come into Vertex AI, they've created a notebook where we're at right now, and there's the notebook we're in. It's like mirror, like almost a, what is this, a regenerative image of itself inside of itself here. And then within the notebook, it's going to interact with pipelines. That's what we're about to do right now. And then at the end, we're going to interact with the endpoints to get predictions. So let's scroll on in. Now the first part is like all the other videos, we are going to first create some parameters to use down below. So mainly you need to worry about the project ID. I've used StatMikeDemo3, whatever you've been using along, you're going to want to replace that. We're still going to need to tell it what type of container image to use for scoring. The exports from BigQuery mostly use TensorFlow. If you have an XGBoost or a booster model over there, it creates a booster file that would require a different image. The minimum compute size, we don't need a big one. We're going to use N1 standard 4. The target variable that we're going to be trying to predict is class, and the variable we might want to omit from the training data is transaction ID. We have it to identify the unique rows, but you don't want to train against that because it'll never repeat in the future. It's useless for prediction. All right, so let's run those. Let's import some packages to work with. Just like the O2C series of videos where we worked with Kubeflow, we're going to import KFP here, Kubeflow Pipelines, acronym there. And we're going to also, from the V2 part, we're going to grab some components to work with. We'll talk about what those are in a moment. All right, and then create a client to BigQuery. I'm not even sure we're going to use that. We can comment that out. Oh, we will use it when we do predictions below. Don't comment that out. Initialize AI platform. We're going to build a pipeline and then submit it to Vertex through that AI platform API there. So initialize that. Let's create a timestamp, a bucket. We need a URI where we're going to store stuff out in cloud storage, to kind of move it around. We need the service account. This notebook's already running in Vertex AI, so it's running on a service account. We want to grab that service account so we can also run the pipeline components using the same one. We're already authenticated against it, so we don't have to worry about permissions that way. Let's create a local folder to store things in that we're going to work with, and we'll move them to cloud storage so that they can be used by the pipelines. All right, we're in the heart of this. This is the part we're going to dig in and we're going to build pipeline. Now, in the O2C series videos, we use components, but we use pre-built ones where all we had to do is map input variables and use output variables from component to component as we wanted to create our workflow. In this video, there are existing components for a lot of Vertex parts. But I wanted to take advantage of the fact that it's really easy to build custom components. They're just Python functions, def, function name, and inputs and outputs. So for every part of today's graph, which is more complex than the one in O2C, it's not horrible, we'll see it, it's easy. We're gonna build Python functions that are components. Now the way you do that, we jump right in. We're gonna wanna build one that gets model metrics. Now I wanna do this custom. I need to get record data from BigQuery. I'm going to choose the test data from our fraud prepped data set over there we've been using through all these videos. I'm going to bring basically it and predictions over to this component. It looks like I'm in the notebook, but remember I'm compiling this to go run independently in the pipeline. The way I do that is I've imported this part of Kubeflow Pipeline called component. What a component I'm doing here is the component's actually a function. I'm using a decorator to that function to essentially pass it my custom function into that function. What decorators do is they say, pass this function BQML eval into the function component and give the sum of them the name BQML eval. So I can refer to it as BQML eval and let some magic happen with this pre-built component function that'll do a lot of things like automatically say, well, you're using this component here and it has this output, and this one over here has its output as an input. So I know that's a relationship that forces them to run in a specific order. That kind of automatic behavior makes these really easy to use. You don't have to do the plumbing so much as you just do inputs and outputs, and it sees the dependencies and runs them in order for you. So what do I need here for eval? I want to essentially go to BigQuery, get the subset of records that are test. I want to get the actual label and the predicted label. That's a SQL query. So here's the SQL query in a string. Select the target variable and the predicted values from ml.predict. Name the model. In this case, it will be the logistic regression model. Select, well, whatever model you input. I can reuse this one component to do the old model and the new model. So the model is an input. I will one time input, the fraud underscore LR model that we built in O3A, the logistic regression model. And then the other time I use this component will be whatever new model we build down below. So that's parameterized. It will run this and bring it over to a data frame in the component, not the notebook, in the component that's running. And I will use scikit-learn. I'm going to import that in the component and use its functions for average precision score and confusion matrix to calculate those with that framework. I'm basically doing this to kind of illustrate you can customize this however you want. I could have actually asked BigQuery ML to give me a confusion matrix or give me evaluation metrics. But I wanted to show that perhaps I really do like this area under the precision recall curve, kind of the way scikit-learn estimates that across that range. So I want to use this specific piece, average precision score, to create an overall metric for my model. So I do that, and then I'm going to log it. I'm going to go metrics. Well, look here. I've got a variable metrics that I've also used these custom Kubeflow components, one called output, and a specific part of output, and this is kind of broadcasting out of the component a value output that is a type metrics. What's great is those are going to show up in the pipeline where I can view them. We'll see that as soon as we run this. And there's a specific one also for classification metrics where I can pass it, the log confusion matrix, and I can give it labels like, hey, 0 is not fraud and 1 is fraud, and pass it the confusion matrix from scikit-learn, where I give it the predicted or the actual value and the predicted values from that data frame, and it will present that graphically for me in the Vertex interface. We'll see that. All I'm doing is passing the data here. All right. I'm going to want to make a component that trains a new model. That I'm still going to use BigQuery ML. So inputs, things like projects, the var target, the variable to emit, a model name, the data name to work with, the BigQuery ML model. I'm going to want to output that as an artifact. We'll see what that means in here. It's still just a BigQuery query. And then as I scroll further down, I see what I'm doing is I'm running that job just like I did in O3A. I wait on the results of that job, and then that output variable of my component here, BQML model, I'm going to go to it and register an object called a URI that is the path in BigQuery to the model I just created here. So that's going to get broadcast. The component will run and it'll broadcast this variable that's the path to the model, so I can use it later, to run the eval component and say, we'll go to that model and bring over to that component the predicted values and the actual values, so you can then register the evaluation metrics of that model. I'm going to make a little function. This is probably the easiest example of a function. It brings in two values, a base metric, a challenger metric. If the base is less than the challenger, then make a Boolean variable replace equal true. If the base is not less than the challenger, that means the base is better, then replace as false, and then return that replace variable true or false out of the component. So now I can use that to make a decision whether to run further components that are going to do the replace actions. See what that means in a moment. I need a component that'll do the part where you go to BigQuery, name the model, and say export it to Google Cloud Storage. Well, this one has that same logic from O3B to go to BigQuery, create a client, go to that URI that's now an input BQML model URI, split, get parts just after the forward slashes, the name of the model, so it's project dataset model name, and then go to BigQuery, run an export statement to the location that I input as the now TensorFlow model location. All right. I need a function that'll do all this replace stuff. Now replace has multiple actions. I'm going to put it all in one component because it's kind of like a group of actions. This replace component is going to say, well, I tell it it's going to need and I haven't named this on the ones we reviewed above, but packages to install. Well, a component is just a runtime that's going. I need to tell it, well, what image to use as a base, like what container. So I say use Python 3.9, and you're going to need a package. In this particular package, I'm going to use Vertex AI, so I need Google Cloud AI Platform installed on that. I have inputs. What do I do with these inputs? I go to AI Platform, I initialize it, and then I say, well, I need to find the model that I'm going to be replacing. So the first thing I do, or first I need to take that exported BQML model we just built, I need to upload it. So model, AI Platform model upload, I give it the container, I give it the new models URI, remember we've been passing that around. I need to go to the endpoints that currently exist. I need to list them, and I need to find the one that has a prefix of whatever input, and I input O3B here. So that one we created there, I'm going to find it. And then I'm going to create a list of the models that are already on that endpoint, and I'm going to remember the first one that's listed there because there's only one there. And then I'm going to deploy this new model to that same endpoint. And then I'm going to, when that's finished, undeploy that model that was already there. So I wait till the new one's there, and once it's deployed, it gets 100% of the traffic. And then I undeploy the old one because the new one's getting all the traffic. There's been no interruption of prediction request. That's a lot. It's going to make more sense when we see it graphically. Now I've built these components. Now I need to put them together in a pipeline. So what does that mean? Well, another decorator that says create a pipeline. Well, a pipeline is a Python function. I'm going to call mine pipeline, and all the inputs, and I go ahead and give them their values here. Well, now I can name the components and pass them inputs and outputs. So first thing I want to do is evaluate the original model. Well, let's go to the base, let's call it base model eval, and let's run the component called BQML eval that we built above. And let's give it the project, and let's give it the target variable, and let's give it the model, which is the data name fraud underscore LR for logistic regression, and let's give it the data set name. Well, there it is. Data name came in as a parameter from above. That's fraud underscore prepped. Now let's train the challenger model. Well, I say challenger model is equal to the component above BQML DNN. It's got a project, it's got a target variable, it's got variables to emit. I give it its model a name, so it's going to be the same, fraud underscore, but deep neural net, and a data name. Let's also now get the model eval metrics for that model. Now, I need to wait till it's done, but something magical is going to happen here. On the model inputs for this, I don't have to name anything from above, from the challenger model. But what I can do is I can specifically define challenger model eval, say, hey, go to this project with this target variable and this specific model, get the eval metrics, but right after it, I do this. I say challenger model eval dot after challenger model. So I'm directing it now. It doesn't have an input that makes it have a reliance on running after. But I can specifically tell it, run this after you run that, and it'll wait and do that. It was as simple as that to orchestrate my workflow. Now, once I have the evaluation for both models, I want to run that compare model component. So compare equal model compare, component above. Base metric is going to be the base model eval dot, now I'm using an output from it, dot outputs, and it has a name metric. Now both of these were evals. And if I go up to the eval function that we made, model metrics, it's called BQML eval, it's outputting a named tuple called model eval that has a value metric where it has a name metric and has a value that's a float. So if I do BQML eval dot outputs and say get the output named metric, it'll have this float value that is the area under the precision recall curve. So scroll down to my pipeline and look at what we did with compare. We said, where is compare here? Oops, I didn't scroll far enough. Model compare, the input base metric is base model eval dot outputs named a metric. And the challenger model is challenger model eval dot outputs and get that same variable metric. So those go in, they get compared, and you get this true false value coming out of them. Well, what do I do with that? Compare. So with DSL condition, that's a component that's, you feed other components in your pipeline, but you don't run them unless a condition is met. So what is that condition? The condition is compare output is true. Now it's just a string coming back because even though it was a bool and we're working with it, it got passed out as a string into here. So if the value that comes from it is this word true, then do these next two parts. But if it isn't better, it would come with the false, and it wouldn't even run the export of the BQML model component or the replace of the model on the endpoint. Now I know that was a lot of words, and you may have even used the scrubber at the bottom to click forward to the next section. That's fine, because we're going to see a picture of this when it starts running. So what I want to do is make sure I ran these components. So let's do a bunch of shift enter down this list. Shift enter on the pipeline. Now what you do is locally in my notebook, I've defined the pipeline. I'm now going to use the KFP v2 compiler to compile that into a file in a local directory. Okay. What is it telling me here? Name true is not defined. Now I did make a quick change before we started. Yes, so instead of saying str string function of true, what I should really do here is just write the word true in quotes. All right, that compiled. Now what that did was that stored it in the temp folder that we created at the top of the code. Let's go in there for O3C. If we click into this file, it's a JSON representation of the pipeline we just created. So we wrote all that code, and it did all this fancy stuff of basically organizing it into nice information that can be used by that Vertex AI service for pipelines. We didn't have to write that ourselves. We just wrote simple Python functions. And then after we compiled them, it wrote all the instructions for the pipeline service. So what we're going to do now is move that local JSON file up to Google Cloud Storage so it's available. Now at this point it's in storage, it's a pipeline, it's a file, I can run it in the Vertex AI service. I'm going to use Python to launch it, but this could be launched by like a cloud function on a schedule or after certain alerts happen. We're going to talk more about that as we wrap up at the end. Today we're going to trigger it the first time by, from the notebook, go to AI platform, feed it that file from Google Cloud Storage that's specifying a pipeline and say, run it for us. So first we register it, and then we run it. Now the rest of what we're going to do is graphical. We're going to get to go look at what's happening. So let's go back over to the console. Let's go to pipelines. And so many of the words that I've said that may have made no sense. And I hope you were listening to them because you were following along in the notebook and looking for additional guidance, and you wanted them as instruction to help understand what was going on. But now that that code is in action, we can see, and it'll make a lot more sense. So here we are. We've clicked into the pipeline under Vertex AI Pipelines. We saw O3C, it's running. It's been running for 32 seconds. We see a graphical representation of those things we created. We see, hey, it's creating a deep neural net. If I click on that, over on the right-hand side, it gives me tons of information about what it's doing there. I get node information. I'm sorry, I'm clicking around really fast. Let me slow down, click summary. I see all the inputs that came in, all those variables we named, the values that came into it. I see this little symbol that lets me know it's running. I see it's already executing a BQML eval. Let me click on that one. And I see that it's running that for the _LR model, the logistic regression. It didn't need to wait on the new model to be built to go ahead and get the eval metrics for the previous model, which has been built already. So that's running independently. Now, when I say running independently, you can actually see them running. Under training, while in other video series we look at custom training, we do build custom training, custom jobs and training pipelines. Pipelines run in components, but those components actually run as training custom jobs. So right now we know two are running. BQML is running a component that's interacting with BigQuery to run a deep neural net. Well, at the same time, the other one's running eval. You can see they're two independent jobs running simultaneously. Well, one just finished while we're looking at it. That wasn't the deep neural net. That's going to run about 12, 15 minutes. The eval, that runs very, very quickly. It ran 1 minute here. We can actually now go back over to the pipeline and see the results of the eval directly in the pipeline. What I love about this is the dashboard for our entire model operation. Build a model, evaluate the old model and the new model, compare them. If comparison shows the new model is better, deploy the new one. We can see everything on our dashboard. These are called artifacts, and some artifacts are special. Remember what we talked about registering the area under precision recall curve and even the confusion matrix from that eval component? Well, those, since I register them as that specific type of metrics, I can click them, and this one's the easy one. It's area under precision recall curve. That's just a number. The base model has 0.68 as its metric that we're measuring, which is average precision. Actually, we could go to our code and remember that spot where we're calculating it. And see specifically, it was that scikit-learn piece that I was running right here. And it's the average precision score that I was outputting there. Well, I was also outputting the confusion matrix. If I click that other artifact, I don't just see the numbers, I see the graphical form of that confusion matrix directly in the interface. This is one of the great things about Kubeflow is it's an interface in addition to an orchestration of a workflow that makes it very easy to evaluate. It's like this great cockpit dashboard of your entire operation. I see the percentages of the confusion matrix. I can even click this and see the counts. I see that, hey, fraud is labeled as fraud 46 times. It misses it 7 times. Not fraud is accidentally called fraud 514 times. We talked about that back when we built the model in O2A. It's not a great model, which is why, hey, we should be challenging it. Back in O3A, we built it. We said it's good enough to go ahead and use, but we should build a better one. Well, today's that day where we're trying to build that challenger and replace it. So this is the benchmark. When this is done running, it's going to evaluate the new model and hopefully beat it. And then if that beating happens in the model comparison, it'll run this next section where it runs the export and updates the endpoint. So those are going to run. While they're running, I'm actually going to say, let's go over to BigQuery and see what that looks like, because we're orchestrating BigQuery. You can see the stuff happening in BigQuery. I'm actually just going to duplicate this tab. And that'll open up a second tab with the same console. And in this version of the console, I'm going to switch over to BigQuery from the menu. Your experience will be faster. Things will load faster if you have a good internet connection. Whenever I'm running my recording software, things do lag a little bit. Try not to highlight that often, but I'm going to take the moment to bring that up now. I'm going to click SQL Workspace, go directly into BigQuery. That'll load. Let's not miss it. While that's loading there, let's come back over and just see, is there any progress on our model? This is a interface where you can zoom in and zoom out. You get this overall navigation window on the right-hand side here where you can change your perspective. Maybe you have a very giant workflow that you're working on. This one isn't giant. It's a little complex, doing a couple of things. It has a condition, but it's not as crazy as some examples you'll see if you go out in GitHub and search for KFP. The great part about this is you can make it as complex as you want. You can build every piece of your thought process and conditional logic and different things you want in your workflow, and it enables it, and you don't have to worry about infrastructure runtime. Vertex runs them. Another magical thing is if you're working with TensorFlow and you're using the expanded part of TensorFlow TFX as we call it, to do things like profiling your data and validating your data and doing a lot of things before training, it will automatically export KFP pipelines that also run here. You're going to see that as part of the 05 series of videos where I cover custom TensorFlow models. This is still running here. If I click on it, it'll even tell me how long it's been running. 7 minutes, 37 seconds. Got about 5 minutes or more to go. In the SQL workspace over here, I can actually expand into my project, StatMike Demo 3, expand fraud, where my tables are, but I can also look down here under project history, and I can see that submitted model running. Here it is. I see a clock running on it. I can click this job ID, and I can actually see the code that was submitted by my pipeline component. StatMike Demo 3 fraud DNN. Here's all the options I picked. Let's take a moment to talk about those options. Those options are model type, a DNN classifier. That's a deep neural net, specifically one where the target is classification, not regression. Auto class weights, that's, well, the default's true. I put it in as an option so we could call out that we're using it. But remember, we have an imbalance. We have a whole lot of not fraud and a little bit of fraud. That imbalance is something that's important to how you fit a model. One way you can handle that is to actually kind of weight the importance of rows. What auto class weights does when you say true is it goes and looks at your class, it sees the imbalance, and it calculates the weight to account for that imbalance for you. You can do it manually, but auto class weights is just one of the ways BigQuery makes that kind of thing very, very easy. It does that for you. Input column, label column. So which column holds the thing you're predicting? Well, in our case, it was called class. So we feed it class. How do you want to handle splitting the data? Remember, we have training data, we have evaluation data, and we have test data. Well, we're going to use custom splits. as the type, and we're going to use a column called custom splits to indicate which data is training data and which data is validation data. That's actually calculated here. Early stopping, no, run all the iterations that I ask for. What optimization do you want to use? Stochastic gradient descent's what I picked. What learning rate? That, kind of stepping the size that it needs to meet. 0.001, the default's 0.01. I like to make it a little more granular. How many examples, rows do you want to use before each update? So the batch size, I pick 100. I think the default's 32. Dropout. In deep neural nets, there's a type of regularization where it basically allows some of the nodes in the graph to be dropped, and it randomly picks those at each iteration step. Well, what percentage of them do you want it to randomly pick to do the dropping? I picked 25% here. In deep neural nets, we talk a lot about these in the TensorFlow and in the future the PyTorch section of the videos. Activation functions are when you're connecting one layer to another, you're kind of squeezing information. Well, there's different functions that do the squeezing. Here we're picking sigmoid. That's essentially logistic regression. Maximum number of iterations. You might hear this in TensorFlow called an epoch. It's the number of trips through the data. Step sizes through the data are batch sizes. So in steps of 100, update after each. And how many times do you want to go through the entire data set? Well, that's going to be 10 times. And it'll do a full 10 because I said early stopping false. Otherwise, it might, minimize the loss to a point or say it's futile. I don't think I can go any further. And it'll hit an early stopping rule and it might stop before it gets to 10. I'm not letting it do that. Now, the way BigQuery handles data, we talked about this in O2A or O3A. When you give it a custom split, you want to give it a column that's true or false. Now it's going to use false values to train and true values to evaluate. So whenever my splits column says train, I let the value of custom splits be false. Otherwise, I let it be true. Now, otherwise would have also included test data, except I have a where statement that says where splits is not equal to test, so it never sees those rows. So this big statement is what is running. It's being orchestrated from that component in our pipeline. But we can still see it running in BigQuery. BigQuery is BigQuery. There's no special extra BigQuery for Vertex or for Kubeflow. It's just connected through an API and interacting with BigQuery on our behalf, which also means, well, that job could be running because, well, hey, there's new data, or hey, a month's elapsed and we think things may have changed, or I have a person who built a new model and they've been testing it on some other data and we want to run the official pipeline to truly run it one time and make sure it's better. Okay, let's go back to our pipeline, just check progress. We see that it's been running, right before I clicked that, it said 13 minutes and some seconds, 18 seconds. Let's continue to punch around here since it's only about 2 minutes left. Let's look back at our models and verify that there's no O3C model. There's not. And on our endpoint, the one we're going to be updating, O3B, it should be currently running. It is. It says that it is active. And if I go into O3B, I see that it has the model O3B deployed to it. And it's receiving 100% of the traffic. It's running one node minimum, one node max. When I built that demo and the O3B video and notebook, I kept it that size and I've left it running until we recorded this one. Back to the pipeline, it should be wrapping up now. Click in. In any moment, we are going to see the second part of evaluation happen. And once that's done, Well, we see the links, and it's going to run our comparison. And if the comparison when the comparison finishes, it's going to pass its true false value into the condition. And then hopefully it's true and it's a better model. It will then trigger these nested components to run, which is export our model in BigQuery to Google Cloud Storage, upload it to Vertex, and then an endpoint update that component. Well, while that's running, let's talk about two more things. There is the Kubeflow that we're building, the Kubeflow that Vertex AI is executing for us. That is an open source project. You can go to the Kubeflow website and you can see and get the guides to everything we're building. Here's the main website. If I go in to get started, I see that it has a nice layout for its manual. Specifically, a lot that we've talked about today is if I go under components and I click on Kubeflow Pipelines, we've talked a lot about the V2 SDK's component IO. Now under here is where it talks about things like parameters. That's where the return value of our custom components might be strings or integers or floats or bools or dictionaries or lists. We've done those. Dictionaries, we've been returning named tuples from some of ours. We've also had specific types of output like metrics or models. These are artifacts, and there's specific types of artifacts, models and data sets and metrics that we've worked with. There's also a generic one called artifact, and they have values that we've seen as we built ours, like a URI. This page is where I learned about those things that we just used when we built our components. It has this entire page about building custom Python based components. That's what we built today. If you want to learn what I learned, this is the place where I went to learn it. You see it at dsl.pipeline, how to build a pipeline. This guide is great. You'll find lots of examples also through the official Google Cloud GitHub repositories of community contributions. People built amazing pipelines out there. Another thing I want to talk about is when you're using BigQuery to build models, there's this great page of end-to-end journeys per model. We did supervised learning. We're trying to predict one of the columns is what that means. We've, in the past, in O3A, built a logistic regression. Here's the create model link for that. Here's how to get predictions, or actually the next table down shows how to use those models. Here's how to get predictions. Today we're building a deep neural net. You still use ML Predict to get predictions from that if you want. To build them, I would click here and say create model. What's the guide for that? That'll load a page that'll give me all the instructions on how to build a deep neural net with BigQuery. Here's the guide. We walked through our build. Well, here's a clickable link where I can say auto class weights. What does that do? Here we go. It even tells me what it's doing when it does that. I get more information. I can go through this guide and I can build a better model. Now, if I go back to my pipeline, I see that indeed the model did run. I can see the metrics from the run. I can click this and I see, ooh, my area under the precision recall is 0.65. Now, we already know from before when we clicked this model, it was a 0.68. So my model actually failed to be better. Let's click the evaluation metrics. See the confusion matrix for this model. And look on the item counts and we see, well, I guess it's just not better. Let's remember this. Let's see, 45 were correctly predicted to be fraud and 8 were of the fraudulent ones were not fraud. If I go look at the confusion matrix for the base model, item counts, well, 46 versus 7, that's a little better, but the problem is the 514 not fraudulent ones that were classified as fraud versus the new model, 237. Well, it does not build a better model by the metric that I pick. So even though my eyeball looks at it and says I might want the new model, it didn't meet the criteria that I set. So what we have to do now is we have to go tweak our model code, rerun this pipeline, and see if we can build a better model that will replace this. I can even click down here and into my condition, and I can see it got a condition of false, which means it didn't even bother executing the contents of this. So what I'm going to do now is I'm going to go over to the title screen and give myself some time. I'm going to build a new model. I'm going to come back when this pipeline is running a replacement from a better model, and we'll walk through that. So we're going to pause here, and I'll be back. In your time, this will be just a few seconds. In my time, it'll be about 15 minutes. I know which change to make this happen. All right, we are back. We're going to briefly look at what's running. I'm still going to pause again. Let me share my screen. What we see is we have a new version of the pipeline running. The previous one ran the 18 minutes and 11 seconds. The new one's running, but the reason I wanted to come back in why it first started is to show that there's this idea of caching involved. While it's running the BigQuery DNN again with some change parameters, it could have gone and ran the BQML eval function for the old model again, but it didn't. It cached the value from the previous run, and it knows that the component hasn't changed. So there's no reason to rerun that. That idea of caching is great because sometimes you have a very complex pipeline and you might just be troubleshooting one part, or only one part has an updated piece of information, and you don't want to rerun the entire, maybe this is running for hours. In this case, we didn't get lucky. The longest running part is the part we did change. The DNN, it sees that I changed 2 parameters on the model that I submitted. But I just wanted to jump back in real quick before this finishes running, and I come back finally and show that this has this symbol saying it's cached. It didn't rerun it. Skipped because this step was reused from cache is what pops up when you highlight over it even. So let's let this keep running. And then come back when it reaches the eval step here. And we're back. Let's bring up the screen. I think I caught this just in time. What we see is that the model finished running. It ran the evaluation of the model. It found an area under the precision recall curve that is slightly larger. And what we should see now is the comparison will evaluate to true. It should replace. And we should see this part of the pipeline start proceeding. So any moment, remember this was a really, really simple function. 2 numbers go in, floats, it evaluates. Is the baseline less than the challenger? And if it is true, it gets passed into this conditional replace model component. All right, you can practically count down. This is going to happen any second. And we're going to orchestrate this quickly. Once this happens, we're going to go over to these other tabs and we're going to watch the model upload. We're going to watch the model deploy. We're going to watch all the steps proceed. Look, okay, so it did come in. It evaluated. It found true. True means it went into the condition. It started the export. What we're going to do now is go over to models. We see there is no O3C, but if we hit refresh, refresh again, that's going to happen. We can actually watch the component and know when to hit refresh. Component's been going about 32 seconds. We could also go over to Google Cloud Storage. We could go to the folder path and we could watch when the model arrives there from the export. Actually, now that I think about it, we put the upload as part of the update. The export would be in Google Cloud Storage. So let's do that. Let's hit the menu here. Let's go to Cloud Storage, browser. We were already in BigQuery. We could probably watch the command for export model come through. There's a lot of ways to do this. What I'm really just trying to do is illustrate the pipeline is just orchestrating things that we've done in other videos. But the automatic nature of it makes it very compelling for automating the entire workflow that you might want to happen regularly. So click Stat Mic Demo 3. We'll drill down to the O3C folder. Fraud. Models. These are all those variables we create at the top of the notebooks that create these folder paths for us. O3C. And once we're in O3C, we're looking for like a saved underscore model.pb kind of file. And there it is right there, 8:24 p.m. It's 8:26 now, so that happened while I was drilling in there. So now we see that the model export's done. It created this nice artifact here that has the directory into that folder stored as a URI. Remember, that was that model type that we were outputting, and then the input component is inputting that. We can click into the input. We can see that coming in, I believe. Let's see, hit summary. Yep, the URI coming in. Stat Mic Demo 3, fraud model O3C. So that is coming in. This is now going to kick off a set of steps. We know the first step is loading the model. Let's refresh and see if that's happened. Now we see O3C here. Let's quickly jump over to endpoints. The same endpoint we looked at earlier for O3B that had the O3B model. Now we're going to look at the endpoint O3B, and we should see it's in the process of deploying the O3C model on it. Clicking into that. Now this is the part where I'm going to take a moment. Well, we have a few minutes because it takes a while to deploy a model, like 5 or 10. So we can catch this, but let's describe what's happening. If you send prediction requests to this endpoint right now, they will be served. Now they will be served by the O3B fraud, that timestamp model that we did in the previous video. Because that model is ready, it is receiving 100% of the traffic. Now, what our component's doing is it's waiting for the model to finish deploying right now, the O3C model. When it's done, let's go back to our code and refresh our minds about what it's asked to do next. Let's see. So this is the replace model and endpoint. The first thing it did was upload. We checked, that happened. The next is it would find the endpoint and find the old model, the current model, and then deploy to the endpoint this new model. And after it's deployed, give it 100% of the traffic. So once it's confirmed that that model is deployed and it's receiving 100% of the traffic, then the last piece of the component is undeploying the old model, the O3B model. So that is going to run for a moment. Let's actually take time to do our Q&A while that finishes, and then we'll be able to do predictions and wrap up after that's done. So let's jump over there. Hi, Mike. When would I want to run a pipeline like this? This is the great part about pipelines, is since they're automating many steps of a workflow, and they're not relying on me to come into a notebook and run it. Like that one part of the notebook, that last thing we did where we, compiled the pipeline and we moved it out to the bucket and then we moved it over to Vertex Pipelines, but then we hit run. Well, that run action could be part of nearly anything. We could be using Vertex AI's model monitoring and watching predictions go through that O3B model and see things like model drift. What is drift? It's where, hey, predictions or inputs for prediction over time in these little time boxes, they start having different distributions. Well, that tells you that the thing that's asking for predictions behaving differently, so perhaps the model that you're requesting isn't necessarily the right one. That would be a good time to consider retraining. Taking new training data, fresher training data, or adding fresher data to the original data and retrain the model with it. Another is this training serving skew, where you have the distribution of the training data that you originally trained with, and you have a distribution of recent data. And when you compare each feature's distributions, you see some of them have a delta, a deviation. You could do a statistical test and say, hey, this distribution has significantly shifted. When this happens, at that point, you know that the model that you trained isn't necessarily applicable to the current data. That is a really good trigger to say, hey, I need to freshen this model. I need to retrain it. Another is sometimes you say, well, every day I get 100,000 new predictions, anytime a counter hits, say, 300,000, automatically trigger retraining. It could just be, hey, I want to make sure I retrain on the first of every month. Any of these scenarios, whatever fits your business or your use case, are valid instances where you would want to then have an employee like me go in and grab fresh training data, build a model, evaluate that model versus the current model, decide if it's better. If it's better, go through the actions of deploying it to the endpoint. Well, if I can bottle all of that up into a pipeline, I can automate it. I can make any of those things that are action-based alerts. Just a pub sub message may trigger, any action that happens. Or if it's on a schedule, Cloud Scheduler would be a really great tool to say automatically run this pipeline on this day of the month or after this much data. It could just be employees are constantly trying to build a better model, and a process goes through and sweeps up the current best model in a repository, like a GitHub repository, builds that into the component and runs it because it sees a new model. All of these are cases where you've automated the operational part, and now the people who build models can kind of focus on the best architecture for the model and not have to worry about this part because it could flow nice and simply for them. That's my favorite use case for what I'm going to encapsulate into this notebook in this video. Challenger models that are coming from a different number of sources, automatically being triggered. Now, what triggers? You could even have an organization that's doing very fancy things with data, and maybe they're using Airflow, Cloud Composer in Google Land, and having that process automatically triggering this Kubeflow pipeline. With that, let's jump back over to our notebook and take a look at our pipeline. It has finished. We're going to go over to, all right, let's click endpoints again. Get that to load for us. All right, we'll click into O3B. And we should see one model deployed, which is the O3C model. Here it is. It's ready to receive prediction requests. Let's go try that out. And that's going to bring up one more little piece that changes this time. Let's see. Our notebook is here. Where are we at in our notebook? Scroll down. We've run our pipeline. I have this little piece of code that pulls the pipeline, runs. Perhaps you're not in the console and you might want to see that same information about all the different runs. There's a screenshot of a completed pipeline here for the folks that are just checking out the notebook on GitHub. Prediction request. Very similar to all the other notebooks. What we're going to do is we're going to go to BigQuery. We're going to grab a couple of records from the test data that we can then send in for predictions. We'll take a look at the first 4 of those records, and then we're going to construct a row of those, one sample, into a format that would be easy to send in. I'll even uncomment this, and we can take a look at that so we can see what we're working with. It is a dictionary of key value pairs where the keys are the feature names and the values are the values from that row that we've picked. So what we want to do is first use the Python client, and then use, say, a REST client, and then use the Google Cloud command line interface called gcloud. What we're going to find is if we do it the way of the other notebooks, and you can try it, you'll get an error back saying that the model signature isn't found. Endpoints running models, especially like TensorFlow models, have expected names of the signatures. In the case of Vertex AI endpoints running this particular container that I've picked, it's expecting a signature called serving underscore default, which happens to be the TensorFlow 2.0 Keras default for model save files. In Kubeflow Pipeline, or in BigQuery ML, when I ran a deep neural net, its architecture was running behind the scenes for that model type, exported a TensorFlow save file. That loads fine, but the name of the model signature is actually predict. So when you run the regular endpoint prediction request, you get this error saying the model signature isn't found. It's not correct. Turns out there is a function in the Vertex SDK that's perfect for this situation. It's where you ask for a raw prediction. You just send in a raw like HTML blob, and it basically doesn't try to interpret it, reads it, and then returns a prediction request. Well, when I do that, I can include additional parameters like the model signature or the signature name. So let's look at this. I'm going to go to, first I have to go get the endpoint. Remember, the Kubeflow pipeline ran outside the notebook, so the notebook doesn't know what the endpoint's called. So I'm going to run this piece here where it lists all the models that are all the endpoints and finds the endpoint that starts with the name O3B and returns that. Let's hit run there. And then I'm going to create a link to the prediction service client for the API URL here. Now I'm going to use the Google API HTTP body protobuf type to construct an HTML message to kind of send into there. It's going to contain that same JSON new observation that we created. So here what we have is I'm going to take instances and make it a dictionary that has a subdictionary of instances key with that new ob in a list. You could actually send multiple instances in for prediction. And then I'm going to give it another key value pair that is signature name with the value predict, a string that says predict. That's the name of the signature name. That's that additional piece that I'm wanting to supply here to kind of direct the scoring to the right model signature. Then I construct the HTTP body from that instances piece using this function I loaded. And it's just data equal, JSON dump that instances stuff, encode it UTF-8, and HTML, I have to give it a content type. Here I'm giving it JSON, so it's application/JSON. I can send that in. And now I can ask for a prediction, which is say, go to that client that I set up, predictor, and go to the function raw predict and give it the endpoint. I found that earlier, and then send it that HTML blob and interpret the response. It's a string response, so I use JSON loads to convert that string into JSON. And when I do that, I find out that it says, hey, predictions, all class IDs, it sees 0 and 1s. It's logistic, and it's giving a prediction of 0.099999. It's very confident about something. All classes 1 0. Probabilities of each class. It says probability of a 0 is 5 zeros and then a 6. So it's not a 0. And a probability that it is a probability that it is I think it's the order of all classes. So probability of 1 is very, very low. Probability of 0 is very, very, very high. So it's predicting a 0 here. It gives you the logits. That's from the logistic function if you're wanting that for information. Class IDs, it's saying, hey, predicting a 0, I believe here. We can actually go to the original record that we're passing in and see what the true value was. True value is a 0, so it is predicting correctly. Now, if I want to do the same thing with REST, I can basically compile that new ob dictionary, key value pairs of feature name, value, and I can put it into a file. I'm going to call it request.json, and I'm going to do that same idea where I constructed of instances with a list of the one observation and another key value pair of signature name and predict. When I construct that file locally and then pass it through with the curl command, Notice that I go to the same endpoint, I ask for raw predict, and I give it that local file I'm sending it in. When I do that, I get a similar dictionary response. And then finally, if I wanted to use the command line interface, I've repeated the same line. It reconstructs the same request.json file. G-Cloud AI endpoints raw predict instead of predict in the other notebooks. Endpoint name split. That means take the name and kind of get just the last piece, the ID of the endpoint within a region, and send it that request.json, and it gets an identical set of numbers back. With that, we're done with the notebook. We have hopefully made sense of all these. If I haven't, then let's discuss how we might get more information. Let's go here and do our wrap up. So what can we do from here? The most important thing you can do is the last thing I'm going to mention. The least important is the first. If you like this, hit thumbs up. It really helps. If you want to talk about it, let's go down to the comments and just talk about this, and I'll respond to anything. If you want more content like this, hit subscribe, and then the bell will even give you alerts when I post videos like this one. But most importantly, let's collaborate. And the way we collaborate is go to the GitHub repository where this notebook is at, hit issues at the top in the banner, and start a dialogue. Things you think I missed, things you think could be done differently or better, ideas for new content that this may have triggered, or you want to know, hey, could I do something like blank? I'll make that into a new notebook and I'll make a new video out of that. Let's collaborate with that. And with that, I want to say thank you for your time. Let's work together to make the practice of AI and ML more collaborative, accurate, and approachable to a wider and more well-connected audience. Thank you and have a great day.